So, sorry, no Portuguese. It's going to be in English. It's not going to be too fast. So maybe you can understand or you get the translation. So I'm one scientist who works on a global basis, and I will make few references to Brazil. You will have to make yourself the inference or the transition to Brazil. So today I will make a diagnosis. We have a patient, a patient that is the ocean or the waters of Brazil that are sick. Today is a diagnosis. Tomorrow, or my other colleagues here will present some remedies, and tomorrow I will also talk about remedies. So today, if I'm negative, it's only because the diagnosis has to be done. I will talk about 4 different things. Catch trends, because we need to know the catch in a fishery. Effort trends, because what we do to catch fish is our input to this. The catch effort, that is a measure of abundance in some countries, and the effect of global warming on fisheries, because all of this is modified. Everything is going to be and is being modified by global warming. And so when you work on a country, when you work in a country, you usually don't need the data that FAO produces based on countries' submission to FAO. But when you work internationally, for example, if you do a consulting job or report for the World Bank or for the World Trade Organization or the OECD, all these reports that determine global policies are based on FAO data. And the FAO data are based on submission by the countries. Each country submits data to FAO, and these are the catch. And the catch, over the years, I have used the catch of the world for various studies, but it turns out that the catch is not right. It has lots of mistakes, and these mistakes are not random mistakes, which would compensate for each other. They are systematic mistakes, systematic errors, because the countries do not cover all the fisheries that they that occur in their waters. And we can, however, correct for this problem by doing something that maybe we have invented that we call catch reconstruction. That is attempting to put all fisheries, to account for all fisheries that are occurring in a country, all of them, even the one for which there is no data. And this is a bizarre thing. How do we invent data? No, we don't. If you know that there is a fishery out there, for example, an artisanal fishery that for which there is no data, but this fishery supplies hotels, as in the Bahamas. I was recently in the Bahamas, and there is lots of tourism there, and the fishery that supplies the hotels with fresh fish is not monitored. The person who did the reconstruction in Bahamas went to 16 of the major hotels and got the purchase of fish. And from that, we could infer a huge sector, a huge artisanal sector that is not covered by the Department of Fisheries Statistics that documents a fishery. We can generalize this observation that every fishery that is a social process, it always will throw a shadow on the rest of society. You cannot operate a fishery without anybody noticing. And noticing is having an idea of how big it is. And how big it is, you can approximate. And the estimate will always be better than putting zero. Because what you do when you ignore this fishery, you actually say it is precisely zero, the catch. And that is always wrong. So the reconstruction is based on these two principles, that a fishery cannot occur without throwing a shadow on society from which you can infer its catch, and that a catch of zero is always wrong. What we do actually is we look what the country reports, what it reports to FAO, and what it reports to itself. That's the reported catch. Then because we always have experts, national experts who help us with this, we always look at what fisheries are missing. They always will know, if you look at the catch reported to FAO, there will be species missing. They are caught, they are missing. We find alternative data source, and there is in all literate societies, in all societies that write, and that covers now most of the world, all over the world, you find written stuff about everything. And for example, a source of data that has been totally surprising, that will be surprising, is the feminist literature. There is gender studies that study women fishing. And they have numbers about how many women fish and how much they catch. That is the subsistence catch. So in our reconstruction, 200 of them, we have lots of citation to the gender literature and literature about. Anyway, we got from each of these different sources, we got anchor points, estimates for the catch of a given time, at a given time, in a given place. We expand this to the country as a whole. For example, to all women fishing, or to all artisanal fishing, or to all provinces. And we interpolate between them because something that you don't observe is usually happening. It's like the tree falling in the forest. We know it is happening. And we then add the catches. And we experience very often that people who have helped us do that fishery, that fishery, that fishery, they're all okay with the fisheries. They're not okay with the sum because they have never summed it before. And they say, we don't catch so much. But you told us that A, B, C, D, and so on. We have some countries that are not democracies. We have co-authors that were afraid of the result. Anyway, and then we have a last step where we assess the uncertainty using various methods, for example, Monte Carlo simulation. For example, this is the result that presented for Australia. I recently was in Australia, and this is the catch. The dotted line is the reported catch, and the addition is the discards that are never included, even though they are caught. These are fish that are caught, and recreational fisheries, and that are not included by CSIRO, even though they know it, and the Aboriginal fisheries that are not covered. This made it in a newspaper called The Australian, but in Australia I told them this is not a critique because CSIRO, the research organization, does a good job. It's simply that they are not mandated to cover this other stocks. And you see Australia is also going down. And the biggest example, the most interesting that I'm presenting to you is Africa, because you will see there something that you did not expect. The thick line is the reported catch. You see that they don't report even all the industrial catch. But the artisanal catch is not reported. The subsistence catch is not reported in Africa. This, by the way, is 22 countries, the sum of 22 countries, from Morocco in the north to Namibia in the south, 22 countries. And so if you are a consultant for the World Bank, or you do a study, a dissertation of what happens in West Africa, you will capture only half of the domestic catch using the FAO data, half of the domestic catch. But in reality, you catch 1/4 of the catch because the foreign fisheries are never counted. The foreign fisheries are reported to FAO as happening in a large space called, in this case, the Eastern East Atlantic, Eastern Central Atlantic, and the Southern East Atlantic. But you don't know for what countries. And you can see here that the legal and illegal catch of foreign fishing, mainly European and Chinese fishing, is half of the catch of Africa, and in the EZ of the countries in Africa, and only 1/4 is reported at country level. And Brazil, there's a whole team that estimated the catch of Brazil, and it is called EPIC because it actually, Katia, my former PhD student, now a professor in the University of Segep, she assembled a whole team from the whole country, from the northeast to the southeast or whatever, and this team assembled all the sources, and this is the estimate that was obtained for the mainland. We also have estimates for the islands, but they are not presented here. And we will discuss that in more detail in the workshop that we have. This is 1.8 times more than reported officially by Brazil to FAO. Now, this picture, please forget it when you have seen it because it's not published yet. This is the catch of the world as opposed to the reported catch. This is in the paper is not published yet, but it is likely that we have in the 80s caught 140 million tons and not 80, and that this catch is declining very rapidly. And the confidence interval is very narrow because while for each country the confidence interval is very wide, but as you add up lots of countries, the confidence interval get narrower. So do not quote. And yeah. And we can also do the difference between the reported catch and unreported catch by country, by region of FAO, and you can see that the biggest difference is actually in the Arctic. The US and Canada and Russia do not report any catch from the Arctic. The Inuits don't fish, but the Inuits do fish. And one major difference is also in the Indian Ocean, where in countries such as Vietnam, Burma, Indonesia, and so on, report statistics that are going up, but it's not real. It's politics. Now, why is the global catch declining? It is declining because effort worldwide is excessive. And it is increasing in the manner shown here. This, the y-axis is the sum of the power of the engine of all boats in the world. There is a database of boats in the world, and the engine, you can add them up. You cannot add the length of boat, because a small boat plus a big boat is not an average boat, and it's another big boat. But you can add up the power of the engine, and in kilowatt, and you can add up, and it will it will show this immense increase. And essentially the increase is in Europe and in Asia, where especially China has a fleet that is growing like crazy. The decline of the catch per effort, the decline of abundance, the decline of catches were not seen because fisheries expanded. All the fisheries of the world, they expand. And this is an example from Spain. Spain in the 50s was fishing around Spain in the North Atlantic, and in Canada, and a little bit in West Africa. And now Spain is fishing in the whole world. Now this expansion of fishing is typical for distant water fishing countries. There are about 15 countries like China and Spain and France and Taiwan and South Korea that have distant water fishing. And they come and fish in Brazil, and they come and fish in the waters of India. For example, the Indian Ocean, there is no Indian fishing in it. There is French fishing, Chinese fishing, and so on. And the same thing of Brazil, everybody but Brazil fished there. So basically, the expansion of fishing that everybody does is constrained by the one who have expanded before. And this is a study that we did for the Commission, the European Commission. That's the expansion of Chinese fishing since 1985, when China began to fish in foreign country. Now it fishes in 93 countries. And it is not, the only place it's not fishing is the Caribbean and the North Atlantic. This expansion is not only in space generally, but in depth and toward the south. The industrial fishing began in the North Atlantic, essentially, and a bit in the North Pacific, because you need an industry for industrial fishing. We must make boats and deploy boats. And the blue shapes show the area of the world that is every new decade is taken over by fishing, and you can see that the center of these areas, if you plot them against latitude, goes toward the south. So basically, the fisheries move from the north gradually to the south and the southern hemisphere. So a better way to express the expansion of fishing and to compare different countries is to account for the fact that catching a ton of tuna is not the same as catching a ton of sardine. If you catch a ton of tuna, it implies that this ton of tuna has consumed, before they were caught, 10 tons of sardines. And this sardine had consumed 100 tons of zooplankton. And this zooplankton had consumed 1,000 tons of phytoplankton, algae, because the conversion efficiency from one trophic level to the next is about 10%. So if you plot every species that you catch at its own level in a food web, and you compute backward how much phytoplankton is embedded in that fish, you can compute how much primary production is consumed, is used by the fishery. And then you can compare this amount of primary production with the primary production that is observed from satellite. So you can relate for every cell on Earth, every place on Earth, how much is taken and how much is produced. And the ratio of this is the primary production required by the fishery. And we can make a map. it's very new, it's not yet published, a map of primary production required in the world in the 50s. And you can see that in coastal areas, the primary production required was very little, was big already in the north especially, but in Brazil it was very little. And I used that in Australia a few weeks ago, because Australia had, like Brazil, almost no red. Then that's now how much primary production we use. Okay, that's how much primary production we use. And again, Australia has little, but Brazil has lots of red. So we use 30% is red. We use a lot of primary production. That indicates that the state of the resource is going to be similar to the state in the north. I will skip that. So if we look at the catch per effort, this is a study that we have done a while ago that shows the catch, the reported catch, FAO catch, not the new catch. And the effort and the catch per effort is corrected for the spatial distribution. If you cannot simply divide the catch by the effort, because the catch per effort is distributed over space, and this introduces a bias. Anyway, this version is corrected for the spatial effect, and it shows that basically the catch per effort of the world has declined by half. So we have really less biomass in the sea, and the effort is increasing further. Meanwhile, things are heating up, and we know that lots of fish species are moving toward the poles. For example, in the North Sea, at about 5 to 10 kilometers 10 to 50 kilometers per decade, they're moving toward the pole. And there are lots of papers with observations like that. And we have taken the maps that we have of all fish, because the mapping that I showed you, it requires maps of the fish that we catch. And so we have mapped all fish in fishery statistics in the world. And if you take one fish, you can see that this map overlaps with the temperature such that 15 degrees is, you can see that 15 degrees is a good temperature for this fish. It likes 15 degrees. So if the temperature predicted by simulation models for the future is moving, is increasing, the fish will have to move north, in this case in the northern hemisphere. And you see that this fish occurs in Taiwan. It's a bit of geography here. In Taiwan, doesn't occur in southern Japan, doesn't occur in North Korea. But a few years later, it will, because it will occur in the Bohai Sea in North Korea, and it occur in southern Japan, and it will be extinct in Korea. This can be generalized. It also, for the southern hemisphere, I don't have one for Brazil, but for the southern hemisphere, you have a fish that we did a study on Western Australia, and they decline also. And the result of this is that for the world as a whole, there will be invasions, fish are coming into new areas, and extinction, species extinction. And this implies that fish will move, and when a fish moves, it takes with it the potential of being caught, its cat potential. It takes it with it if it moves. And this map was generated, that's a prediction of a possible scenario or for the global fisheries changes, and you will see that the prediction is that the tropics, that is northern Brazil as well, will see a reduction in the in catches only because of global warming. This doesn't account for acidification and doesn't account for other factors. Global warming itself will reduce the catch simply because the fish will go. So, but this stuff is not in the future. This stuff has already happened before in the last 30 years. And you can see we have invented a new indicator. It's a mean temperature of the catch. Remember this fish in China that had a temperature, 15 degrees? That's the temperature it likes. Well, every fish has a preferred temperature, and it doesn't change much because this is deeply embedded in the physiology of the fish. They cannot change their preferred temperature very much. So if you have a catch like here, you can compute the temperature of the catch. Is the preferred temperature of each of the component species multiplied by the weight of that species. The mean temperature of the catch then can be looked at worldwide. For example, the mean temperature of the state of, I don't know, of Bahia state, or the mean temperature of the catch of France, and so on. And the mean temperature of the catch in temperate, in non-tropical areas is exactly parallel to the temperature itself. In other words, we have invented a complicated thermometer. But in the tropics, the mean temperature of the catch doesn't increase in parallel with the temperature, because once the fish that don't like the heat are left in the tropical areas, they are not being replaced by other fish that are like even higher temperatures. So this is the reason why the changes that can be expected can be summarized in this. You have, in the 70s, you had a mix in temperate areas, a mix of cold water loving fish and warm water loving fish. And basically they're all replaced by warm water loving fish. In the tropics, however, you had warm water loving fish and hot water loving fish. The warm water loving fish have left because it's too hot for them. And in the future, they will continue to live and they will not be replaced. So there will be a decline in the catch and the species abundance of tropical fish. So the summary, and you don't have to be worried about that because I have done it exactly right. The world catch, also much higher than thought previously, is in steep decline, the world catch. Local decline have long been masked by expansion. Expansion makes decline invisible. Global warming is moving the fish resources forward, and this will accelerate in the future. And one way to deal with this is fisheries management and rebuilding depleted stocks, of which more in a coming lecture. Thank you very much. Exactly, with no watch, just like that.